Okay, finally got laptop. These many days I don't have a laptop. That's why there was a little bit hiccups while teaching. Because I cannot teach in my office laptop. Okay, let me set up everything. Okay, today we are gonna cover a little bit of pointers and array. Pointers is like very important concept. Okay, last time we discussed about functions. Function is nothing but a block of code that performs particular task. So that we discussed. It just simply takes arguments, do work, whatever we have given in that one, and return result. So there are two syntaxes of declaring it. So function is like function prototype. Syntax one is prototype. So it can be like this, like void function, which is like a function which doesn't take any argument and doesn't return anything. And I can return one more thing like void function int a. This takes one argument and return int. So this is like this we define. This is only to tell the compiler that I am declaring a function of which is return int and of name function which takes integer like this. Okay, so this is just like brush up. And second, we have whatever we declared here, we initialize them with the block. Now here we give the piece of code whichever we wanted to execute. Okay, a little bit of example we'll see in program. Now we have local compiler. These many days we used to do an online compiler. So that's because my office laptop I cannot install. So now everything earlier we have Windows XP like that where we can directly download and install Turbo C and Turbo C++. So now IDE is many of the programs we can develop in IDE. So Visual Studio Code is an IDE where it has automatic things like it will if you see now control this. Let me save this as test func. We have to store our C programs in .c extension only. See, it is has in this intelligence which will tell what is the next step. Okay. So the for using these IDEs, it will reduce the development time. So now you see, I just gave this hash include it recommended me what can be the next line. Now starting point of our C program will be like main. We will discuss the doubt question also at the end. So like these two lines I have. So it's printed two times. So now I can make it as a function which takes nothing like print function I can give. So I'm just declaring it now. I'm not initializing or not writing anything. Now I'm initializing it. Now I'm not giving anything. I'm just calling that function. So if you remember earlier, now here I have two lines of code. Now if I want to do the same piece of action multiple times, I have to just repeat like this. Like total, we have like some 18 lines of code. So assume these many times it has in function. Now again I want to repeat the same thing again. So I have to write like this. So if you see the same, it is same piece of code which is repetitive, which is like repeating multiple times. So if you see here, it is not like readable, and at the same time, it is increasing the number of lines of code that has in the main code. If you remember, the execution in C will start from the main. Okay. So instead of doing like this, so we are moving out this repetitive work into a function, and we are just calling it one time. So I'm just calling it one time. So if you see here, there are some 10 lines of code which is in function. But here I'm just calling, I have only one line of code in the main function. So like this one I can call multiple times again. So if you see, there are 20, if you replace this function in main code with the like with the statements that which are having in this function, I have to write like 20 lines of code. But now it is only two lines of code. So that is the main purpose of the function. It is printing that one. So because here we didn't give escape character, it is printing a single line. So now if I remove, if I give only one time, so it printed only that many times. So like this, we can move the repetitive and common code to the outside of the main function, and we can reuse the same piece of code multiple times. Like if you remember a TV remote, there will be like multiple buttons. Think each button has a function. So which is doing a particular task. You are giving an input as a number. It is taking that input number, doing the operation in the TV, and it is returning the whatever channel you have desired for. It is a simple example of a function in the real life. So pressing a key is common for all the 10 buttons whichever we have. So that we can write like a press key. And here we will take the number whichever we have given in the remote. So for that number, it will do the process and it will return the channel, whatever we have. And the same function, like now here in the main remote, we will have like 10, 20 characters or whatever we have. There can be n number of things. So for all of them, we just move out of the common code, out of the main logic, and we are reusing the same repetitive code. So we do by that here if you see like 5 lines of code, if I like there are like some, if you do the math, 10 lines of code is required for each press key function, and we have like 20 keys. So there will be like 20 into 100, like 200 lines of code will be there in the main function, which is like not required. Most of like each 20 buttons have only 10 lines of code. Instead, we moved out of this 10 lines of code outside, this 20 lines of code outside, and we just use the function here 10 times. Then we will have only 10 lines of code, and this 20 lines of code, only 30 lines of code will be having. That's the main usage of the function. Okay. Next we go for the pointers. Pointers is like very most important thing in C, and most confusing part also. You might have seen where we will be declaring pointers like this. Something like this. Okay. Now we'll cover what exactly everything means in that one. As we discussed initial days, so our program will be executing in the RAM. RAM has the memory. Each system will have different kind of memory. Okay. This will be one memory block of imagine this as a memory block in RAM. Before that, let's check what is an variable. Variable is like we will define like data type. It just holds the value of the data type whichever we have provided. Okay. Now what is pointer? What is the difference between pointer and variable? Let's go like proper textbook notation. Variable is the name of the memory location which stores some data. Like name of the memory location. Remember this part. Name of the memory location. So this is like 1021, 1022, 1023, 1024. These are the memory locations. Okay. So now here we are giving a A like 20. So this is the variable name. Here we have the data. So for this data, and here we have the address location. So it a variable just stores the memory location of the data which have we stored. If you remember this one, like we have whenever you see some plots or something like or your houses, so we will be having multiple houses. Each house will be having a different address. Whoever lives in this address can be changed, but this address cannot be changed. Like that, here this 20 can be like 30, 40 or something. And this variable name also I can change multiple times, but this address cannot be changed. That is fixed. Okay. So this is like variable, whichever is storing the data, and the data is stored in the location. And to store this particular address, do we have anything? That is called pointer. Means now I can define one more variable which is pointer by mentioning it as by giving an asterisk, and I want to store this particular address location into this one. Here we have stored data, but here we store memory address by using pointer. I'm repeating one more time. So variable is nothing but the location which holds the data. So now we have the variable which stored the value 20 in the memory location 2021. This variable holds the data which is like 20. Name of the memory location. For this memory, we given the name A, which is storing value 20, which is called as variable. Okay. This memory location we can store in variable. This value, whatever we have. So this one is data. So this one is memory location. Memory location also we can store in a variable. That particular variable we call it as a pointer. A variable that stores the memory address of another variable. This one is different, this one is different. It is storing data, it is storing the address of this particular variable. So 1021 here, 1023 here. 1023 memory location having 1024, which is the address of this variable. And what is the syntax of this pointer? How we define it? So we all know how we define a variable, which is like data type, variable name, and the data of it. Okay. And as we discussed, a pointer is storing address of the variable. So usually to get the address, what we use ampersand. Now this one, there is no difference. What is the difference? Here we are storing the data, here we are storing address. As we told earlier. So if this is same, this is also a variable. What is the difference to make difference between a variable and a pointer? So hash trick. Whenever we given a hash trick symbol before the variable name, that will be treated as a pointer. This address we call it as this symbol we call it as address of variable. So whenever there is an and, it returns the address of this particular variable. Whenever there is an ampersand symbol in front of the variable name, it returns the address of the variable. So if I give here ampersand 20 is there, like a ampersand a, if I give, it returns me the address of this particular variable. Okay, and this particular symbol we call it as value of the address. Means, let me clear this one. So as we discussed, there is a RAM, we have memory locations. Okay, it's 1021, 102, 101, 123, 105, 106, like this. Memory can be or cannot be continuous. Okay. Now here we have variable which is storing 25, which is having of address. So here we give as age, right? Age 20. So whenever I call ampersand, that returns me address of this particular variable. So now if I give ampersand of this one, and now we have one more variable called PTR, pointer. So we gave this one, means this address is being stored in here. Means this address 1021 being stored in 105 location. Now whenever we call asterisk, means value of the address. So whenever we call this one, C compiler will go here in the memory location. It will call the go to this memory location whichever we have, and it will get the data that which we have. Okay, let's see it in a program. So now we have variable age of data type int, which is storing value 22. Now I am declaring a pointer which is storing the address of age. As I told earlier, what is asterisk of, it means it will return the value of this particular pointer. Let's compile this program and execute it. So now we have age 22. So this directly prints whatever data we have in this variable. Okay, because we are directly calling the variable, and the variable is nothing but the name of the address location which stores the data. So it is just returning 22. So now whenever we are calling here, it is pointer. So whenever we are calling pointer variable, so it is returning me the address of it. Okay. So now what we have underscore age, it is star pointer. Star pointer means we discussed earlier. So star means value of, ampersand means address of whichever variable we have. Okay. So now here we got the address stored in the pointer variable. So whenever we invoke star PTR or star pointer, we get the value whichever stored in that one. So just double check it. Now we have here we are printing a pointer, right? Let's check whether it is both are same or not. I am giving ampersand age. Let's save now. Execute. If you see both are same value, age address, percentage age, and whatever pointer. You can see here both is storing in the same, both variables containing the same result. As we discussed earlier, both is having address means this ampersand symbol means address. So this address is assigned to the pointer variable. So that pointer is containing this particular address. So this age address is held by pointer. So whenever we want to get the data that whichever is stored in this particular pointer variable, we have to invoke this PTR hashtag symbol. Then we get the value in that one. We will check one more example, this one only. As I told earlier, so the distinguish between a variable and a pointer is what happens if you give without hash tree some like this. It's giving us just a warning because whatever we are getting here, it's too long. It is not able to store in the into values. It is just typecasting. If you see here, we stored this one. Okay. Now let's do one more thing. Now I am doing star ptr plus plus. Okay, means I am incrementing whatever value we have here in the pointer, and at the same time I am doing this one also increment. Let's check what's the value in age. Actually, if we change something to the pointer, it will directly reflect to the variable, main variable also. Maybe the example is not correct. We'll give it a proper example. We'll get a proper example for this one. Okay. The main concept of the pointer, as I told, it's like it holds the address of the variable directly here, not the data. Okay, where this pointer will get used mainly. If you see, we have functions as I discussed earlier. We have only half an hour. We discussed earlier, we have functions like this, function into data type. We have only one return type here. Means this function can return at a time only one value, and whatever changes we have done for this particular variable declared, it will be limited to this particular block only. So apart from this, it won't be reflected. Now that we call as call by value. We have another function call, we called as call by reference. So here whatever we pass variables, that won't get reflected. There will be no change to the main and the called function. So whatever it doesn't affect the main system code. So it will be limited to only to that particular function call itself. So apart from that function call, it doesn't affect in the main function. But in call by reference, we pass reference of the variable, which is nothing but pointers. By that, whatever change you have done here, it will reflect here. So the change that we applied in this function will get affected to the main function also. So here I pass like four variables from the main function, and whenever the operations are completed, so when I call again this four variables, so the data will get reflected. So it's logically we are returning four return variables, but actually we can return only one variable. That is main alpha is call by reference. So there are two function call methodologies. One is call by value and other one is call by reference. Whenever there is it is in C, the default one is call by value. So what call by value means, whenever we pass some arguments to the function from the main call, the changes are done in a function are only reflected into that particular function block only. It doesn't affect to the main code block. In call by reference, whenever we pass some arguments to the method or function, so the changes whatever done in that particular function will be reflected back to the main function also. So there will be data change will happen to that particular variables or whatever we pass in those arguments. Let's see some programs for this one. So the major let's do addition. Let's start. So earlier we have like discussed there are two types of declaring functions, right? One is like declare and then initialize. So now we will check that one. I will check square, which is taking one argument, okay, and returning nothing. Our main function, we have declare one variable number 4 or 5. Okay. Now I am calling the function, which is by default we discussed like it is a call by value. I am passing 5 and I am printing the value. Okay. Now we have, if we call like this, it doesn't work, right? We have only declared here. We have not initialized the function call. So let's initialize the function call. So we are multiplying this number, doing following. Function. Here we have a number. Okay. Let's compile it. Because the name is different. Here we gave square, here we get cube. So that's why it's not able to identify this particular name. That's why we got compile time error, runtime error. Sorry, compile time error. There are two things, compile time and runtime. So whenever we compile a file, that time if we get an error, that we call it as compile time. Whenever we execute a program, that time if we got an error, that we call it as a runtime error. Compilation successful. Now execute it. So if we see here, here we have 5. We sent number 5 to this square method. It did multiplication. It printed the value, which is like which is like square, printed the value, and again the function returned here and printed this one. So the execution will start like this, right? So it will first come to here, then it will go to here. It ignores here the function call in a stack. Main will be starting point, and then whenever a function encounters, it will add that particular function to this stack. Whenever this one is completed, then again it will, controller will come back to main function again. So from here to it went to here, we did the logic whatever we have applied, and then it added squared the value, printed it, came back to here, and if you see it is number is still same, but we have passed it, right? There is no change to this number. So we just print whatever the value here. Why? Because here this is becomes local to that particular method. So here there will be a copy created and it will be stored into that particular location. Whatever operations we do, that will be reflected until and unless this code block. Once this code block is completed, this one the memory of this function will be cleared and it returns to the main function. So the data available in this stack, it will be like discarded. So it comes to main function. This is by default call by value. It is common in C. It is very like it's by default execution. So to achieve the different one, like call by reference, what we can do is we can pass pointers to that one. So now we are sending pointer here. As we are defining pointer, the operations also should be pointers only. Okay. This one if as it is pointer, to check the value of the pointer, we should do the asterisk symbol. Now, what do you think here it will print? You may get a question in the exam, distinguish between call by value and call by reference. Then you can use example. Sorry, here I'm giving direct value. I should give address, right? Pointer means it should get address of that particular variable. Compile. Okay. It's called the pointer one. If you see here, we have a variable called number with value 5. But initially we sent this number, it went to here, it did multiplication and it printed. So we have value. So inside the function, it is printing 25. And when it came to after executing this function, it came to main function and it printed. So the value still remains 5. So there is no change in this one because this is a call by value. We are not sending any difference one. So now we went inside this square, we are calling square method. Okay, here the value is 5. Here also we sent 5. It came to here as a 5. It did multiplication, it printed 25 and it came back to here. So now if you see here the value still remains as 5. Now we do call by reference by passing the address of the variable to the pointer method. It came to here as 5. Done multiplication square, it become 25. It printed 25 here. So it came back to here and now the value in number also 25. Why? Because we have discussed initially, right, the memory location. So here it is number which is of having value like 102 or 103, 104, 105. So this 102 is stored in, we have one more pointer variable, right, n. So in this it is stored. So now whatever operations we do on this on top of this particular variable, it will be reflected to this address also. So if we do multiplication of some whatever changes in this particular variable, it will get reflected and it will updated to 25 from 5. That's what earlier whatever I was discussing. So now here this 5 value got changed. So whenever we do modifications to the pointer variable, that will be reflected to the main variable also. That's why call by reference, we are sending the reference of that particular variable. We have done some modifications here and we are here to see we are not returning anything. It is a void, but still the value in the number is getting updated to 25. That's why we call it as the call by reference. So here both are same. Only difference is here we are not using pointer, here we are using pointer. That's why there is a small change here. So one example we can use like we can use the same example which can come in examination of swapping two elements. let's swap two numbers. So now have A number 5 and B number 3. Now I should do some operation and I should get A equal to 3 and B equal to 5. How we can do this one? So let's assume we have two buckets of water. One is having 5 liters and other one is having 3 liters. So now I want to shift this 3 liters water into this bucket and 5 liters of this into this bucket. How we can do this one? So to achieve this, we get one more bucket, which is of empty, of capacity 5 liters. Okay, it is empty. Now we pour this 5 liters into this bucket. Now this becomes 5 liters. This becomes 0 liters. Okay. Now in this bucket we have 3 liter. In this bucket we have it become empty. We have third bucket, which is having 5 liters. Now we transfer this into this bucket. Now this becomes 3 liter. This one becomes empty. Assume this one as A and this one as B. This one as A and this one as B. This one is some temporary bucket. And now A is empty and B is having 3 liters. We have 5 liters in the temporary bucket. Now we pour this into this bucket. Now A having 5 liters, B is having 3 liters, and temporary becomes empty. The same we can use to, in the program also, like how we by using a temporary variable. We can swap two numbers by using a temporary variable. How we can do? So instead of temporary bucket, like here, this is also like buckets only, right? These are also buckets only. Like these in the programming language, these buckets are called as variables, which is having holding some data. Real life bucket means holding water. Here bucket holding some data. So we will write one function like swap function, which is taking two arguments into A and into B. Okay. So we will take the temporary bucket, which is temporary variable, and we pour whatever in the A into this one. So now A is assume A is empty, and in A we are sending B, and now B, and now B is empty, and whatever they are available in A, we are giving it to A. So we will give the temporary one. So first we scored or like first we assigned whatever value in our temporary bucket, and whatever value we have in B, we send it to A, and to B whatever we have in A temp, that is we are sending it to B. Means here temporary initially like 5 and 3 if we have. So temp becomes 5. Now here A becomes 3 and in temporary we have 5. So now we are assigning B to B with temp. So it becomes 5. The swapping is happening. Let's see the program. Let's define the method. We are taking two variables A and B. Now declare the function. So now what do you think will happen here? So now we have swap method. So we have x1 y declared. Temp means temporary variable. We are just declaring this is a variable name. So like how we have here x, y defined, temp means temporary variable. In the bucket example, I told right a temporary bucket we are taking, a third bucket. So the same thing here, temp means we are declaring a temporary variable which just holds the data value in the A. It takes the value and again we just reassign it to the different one. Just another variable like how we have defined the x, y, a and like that. It doesn't hold any name, any significant. I can give something like t also to this one. Still it works. It's just a variable name. So now here our execution flow comes to here. We have assigned the values. So if you, as we discussed earlier, this is an example of sorry, this is the swap. We have still x equal to 5 and y equal to 3. We did do swap, right? Why didn't I have one? Let's see here. What are the values here? So here we will be like a, b, right? Let's tell before swap. For swap, this is after swap. Okay, time is enough. So I'll just quickly complete. Okay. So before swap is 5 3. In swap it become 3 5, and again after swap it become again 5 3 because it is a call by value function. So now do the same thing for the with the pointers. Now I'm applying pointers to this one. Okay. Now I have this. You will get this program. You may get this program in examination also. So let me define one more with a call by reference, which is having which is taking pointers as an argument, which is like call by reference. So now I'm assigning pointers to that. Okay, before swap, after swap. Now this one before swap, after swap. I should pass address. If we are passing pointer, if we are taking pointers as an argument, I should must have pass address of that one, the pointer. Save it, compile, well, because we are passing to the wrong method. Our function is which is taking absent means it should take pointer. So here we are sending pointer, but here we are taking only integer data type. That's why it is not able to understand. Compiler is not able to understand. So if we are passing address means the argument should be a pointer, should not be a integer data type. We haven't saved the program. Now we saved and we compiled. Now see what is the result. So now before swap x is 5 and y is 3. In swap it got swapped, and after swap it is still 5 and 3. Now we are calling arguments with which is called by reference. So here we should give pointers because it is 20, it is pointers. To get the value of that one, you should give pointers. Now after swap it becomes it is 5 3 still. Now before swap 5 3. In swap it becomes 3 5. Means swap happened. Now after swap, the final statement, it is like in main. It was in main program. So the updation is happened to the final variables. So even though we haven't returned anything, the execution is completed and the variables got swapped. Even though after the function is completed also. Okay, this we call as call by reference. There is one more doubt asked, right? To explain about how we write program for one, how we write program for 1 plus 1 by 2 plus 1 by 3 plus 1 by 4 and so on 1 by n, right? This I will explain now itself, and again I will explain tomorrow also that many of the people are not there. Okay, let me quickly explain and I will explain in deep tomorrow also. Okay, so this is simple like Once we complete basics, it is we can complete quickly. So without basics, even though if I tell something also it will be not clear. So now we have a arithmetic operation like 1 by 2, 1 by 3, 1 by 4 plus and so on 1 by n. Before this, we will write one more like sum of 1, 2, 3, 4 and so on n. So this we take as like n. Simply we can write a for loop. For int I equal to 1, I less than whatever number given and I plus plus. It starts from here. We declare some temporary some variable. We initialize it with 0 and sum equal to sum plus I. I is nothing but it is like iterative element, right? So initially it is 1. After one loop completed, like plus plus, it will become 2, 3, 4, like that. Whatever we have, right? It is covering here. So at the end, we get the sum value. We can do print sum value. Okay. And same thing here also. And this can be converted to like sum of natural numbers, n into n plus 1 by 2. This also we can use. It can be done in order of 1. That we'll discuss at the end. What is order of 1, order of n? So this is order of n. Again, in algorithms and data structure, we'll discuss about this order of concept. So this is one way, right? So now coming to here, when this is like 1 by 1, I can write 1 by 2, 1 by 3, and 1 by 4, and so on 1 by n. Tomorrow I will explain programmatically. Now for int I equal to 1, I less than n, I plus plus. So in this case, we should do I less than or equal to n. Initialize sum equal to 0. And now here, if you see 1 by 1, 1 by 2. So if you take this into int variable, here whatever we have in the initialization section, what is the for syntax of for loop is like for initialization, condition, and the updation. Here, this whatever he initialized here, it will update how many times we have until the condition is matching. This particular declared value will get updated continuously. Okay. And now here, now we have like sum equal to sum plus initially sum will be 0, and it is nothing but I by I. Now what is I here? Initial. Now whenever the execution comes, so sum will be 0, I is 1 by 1. Okay. Now it went to for condition. Now let's like n is 5 you 1 is less than or equal to 5 or not. Correct. So then it will go for the updation. Sorry, it will go for the updation. It will become 2. Now 2 is less than or equal to 5 or not. Correct. So then again it will come here. Now the sum value will be like initially now 1. 1 after one loop completed. Now again it will be like sorry, this will not be I by I. This should be like 1 by I every time. Because we have 1 by 2, 1 by 3, right? If I give I by I means every time it will become 1. Like 4th loop and 4, it will become 1. So it should be like 1 by I. Condition logic will be like sum plus 1 by I. Okay. This we will see tomorrow in C program, and I will share the C programs to you also. and we'll see more programs coming. So actually, I wanted to complete arrays also, but pointers is a big concept, so we completed all pointers itself. So tomorrow I will explain arrays basics, and then we jump into programs. Okay. Any doubts you can unmute and ask. Okay, we'll discuss tomorrow then. Okay, sure.